Have you ever been frustrated by the amount of time it takes to travel? Are you concerned about the amount of fossil fuel wasted by the transportation industry? What if we could eliminate friction, the largest source of energy loss? The MagLev train is an alternative mode of transportation that solves this problem. Using the power of magnetic attraction and repulsion, German and Japanese engineers have created the fastest and most efficient trains yet. This advanced technology levitates the trains 1 to 4 inches above the track, thus eliminating friction and allowing them to reach unprecedented speeds of up to 310 miles per hour, 5 times faster than your average train. This is fast enough to travel between Boston and Orlando in just 3.5 hours, only an hour and 15 minutes more than a commercial flight. But how does this work? To understand this technology, we must first take a look at how magnets work. Magnets have a north pole and a south pole, just like the Earth. When opposite poles or polarities are brought near each other, they attract. When like repoles are brought together, they repel. The MagLev trains are based off of these principles. One of the coolest features of the MagLev train is the way it defies the restraints of friction and gravity by levitating above the track. Powerful magnets on the bottom of the cars and along the track repel each other strongly enough to lift the entire train. As gravity pulls the train towards the Earth, the repulsion of the magnets keeps the train hovering at a constant height. Because the train is not in contact with the track, it is able to reach extremely high speeds. Simultaneously, magnets along the sides of the track and the train propel it forward. These magnets are placed in such a way that the magnets in front of the train are opposite of those on the train and thereby attract it forward. Magnets behind the train are the same polarity as those on the train, and so they push it forward. To stop the train, the polarities of the magnets are switched. These changing polarities are most easily achieved using electromagnets. Electromagnets are magnets wrapped in wire. When electricity runs through the wires, a very strong magnetic field is created. Changing the direction of this electricity changes whether the magnet is attracting or repelling the train. MagLev trains are truly the transport of the future, and they have great potential to become even more efficient. Because these trains run on electricity, they do not have an engine and do not require fossil fuels, such as gasoline, to operate. Instead, clean energies such as wind and solar power can be used. In fact, if solar panels are placed along the track, the trains have the possibility of being entirely self-sufficient systems. The only real source of energy loss to MagLev trains is air resistance. Luckily, engineers are already looking for a solution. In the future, you may see MagLev trains running in vacuum tubes and reaching speeds of more than 2,000 miles per hour. That's fast enough to get from London to Tokyo in 3.5 hours. MagLev trains are already being used in Germany, Japan, and China. Maybe you'll see one in your neighborhood soon.